Hello, class. It's Mr. E. Good to see you guys again as we start our second day here of math. So, whether you're in Math 7 or Math 8 today, we are going to be doing the same material. That is because, again, this first week, especially before we delve into next week and look at what we're going to look at and the last units that we're going to start looking at as we move through this online course. We, as a math department, decided to keep going with what is the most essential things that we could leave you guys with. You know, if the school year ended tomorrow, hypothetically, what would we need you guys to know? And we talked about how solving equations, one step, two step, and further, is something that continues to pop up in math and is essential. So that's what we're going to look at today. Today we're going to look at two-step equations. If you were in 7th grade, we talked about solving one-step equations the other day. And if you're in Math 8, we talked about scatter plots and finished our unit on that. So today we're going to both look at solving two-step equations and make sure that we've got this essential skill down. So let's get to it. So on our screen here, we've got Math 7, Math 8, two-step equations review. Okay, and so we're going to go through, we're going to have 3 different, or 6 problems, but we're going to do 3 together, and 3 you guys are going to do on your own. Again, if you haven't done this from the previous day, I want you guys to either follow along on the PowerPoint. I'll see if I can upload it differently. But I would suggest finding a way to click on that PowerPoint, download it, and filling in the text box. Or you can also follow along on a sheet of paper. Make sure you're doing one of the two. That way you don't get left behind and you're able to participate in the self-practice. All right, so the first problem we're looking at here, it says solve the following two-step equation. 5x plus 7 equals 32. Okay, if we're going to do, we're going to do 5x plus 7 equals 32. Then, see if I get my drawing tool here. We need to, again, ask the same question we did the other day, which is, how do we isolate the variable? How do we get x by itself? So we say, all right, how do we get x by itself? And if you remember what we learned before, we said we have to do the inverse operations, which means the opposite operations. So if we say, okay, to get the variable isolated, to get x by itself, we have to do the opposites. We have to do the inverse operations. So let's look at our equation here. We have 5x plus 7 equals 32. This 5 is kind of tied up with this x. Okay, right now it's 5 times x, right? It's multiplying. And over here, we just have a plus 7 tacked on. And in my classes, we said, you can think of this as either being closer, right, or the 7's farther away, or reverse Pemdas, right? So if, see if I can write here. So if we remember Pemdas, which is our order of operations normally, parentheses, exponents, multiplication, division, addition, subtraction, right? And it's really parentheses first, then exponents, then multiplication slash division, addition slash subtraction, right? Those at the same time. So if we go backwards, we have to do addition and subtraction first, then any multiplication, division, exponents, okay, and then parentheses. So we have to go backwards. So all that to say, let's start backwards. If we want to get x by itself, that's being multiplied. So addition and subtraction, that's going to come first, and it's farther away from the x. So I'm going to start with subtracting 7 over here. Now, can I just leave it like this? No, right? I cannot leave it like that because I have to do the same thing to both sides. Again, if our equation is a scale, measuring scale, if we take off weight from one side, what's going to happen? The scale tilts. It's not equal. We're then saying something that's not true. We're saying this is equal to this when it's not actually equal. It's inequality. So we have to do the same thing to both sides. Minus 7, minus 7. And what happens over here? 7 minus 7, well, that's just going to be 0, isn't it? And left over is 5x. Okay. We could leave the plus there if we want. Equal sign drops down. And we have 32 minus 7, which is going to be 25, right? I want to make sure I said that right. 25, right? Very good. So now we have 25 equals 5x plus 0. Well, adding 0 to anything, does that really change anything? No, not really, right? So now this is just 5x equals 25, right? Good. All right, so now how do we solve? We got one more step. We did one step, now it's the second step. So this is subtracting subtracting 7. And over here we have 5x equals 25. Opposite of multiplying, if those are multiplying together, right? Invisible multiplication symbol. The opposite would be dividing by 5. So we're going to say divide by 5. And normally I would just use a little dividing line under here. And you can do it either way. If you want to draw these symbols, you can. Old school division symbol. So now we have 5 divided by 5 is, and if I drew it like this, 5 divided by 5. Oh, 5 divided by 5, that's 1 whole, right, as a fraction. So we have 1x equals 25 divided by 5 is 5. So there's our answer. X is equal to 5. So we subtracted by 7 on the first one. We divided by 5 on the second one. And now we have 1x equals 5, or just x equals 5. All right, so there's our answer. Okay, and how can I always check? I can always check by taking my answer, in this case x equals 5, and plugging it back into the original equation. So if I plug that in, 5 times 5 is 25, plus 7 is, oh yeah, that's 32. Okay, so we know we got it right. Okay, so I want you to scroll down. I want you to try this problem on your own. Go ahead and pause the video now so you can check and see if you can do this one. Use a calculator if you need to for the decimals, and then when you resume, we will check the answer. All right, so looking at our equation here, I didn't do it all the way because I wanted you to see this last little bit. But here we have our equation, 2x minus 1.5 equals 4.3. If we want to get x by itself, isolate the variable, we're going to do the inverse operations. So the opposite of subtracting, we can see here first, would be adding, right? So if we want to get this x by itself, we need to do either reverse Pemdas, think of it that way, or this 2 is tied up with this x really, really close, right? They're multiplying, whereas this is just over here on its own. So it's going to be easier to get rid of the 1.5. That's how you can know that that's where to start. Okay, so we add 1.5 to both sides. Negative 1.5 plus 1.5 is going to make 0. That's the whole reason we do this, guys, is so that way this can all cancel out. Okay, so those are canceled, and now it's just 0, right? So I really don't need to put this here because adding 0 doesn't do anything. So now we have 2x equals 5.8, right? 4 and that makes 5. 0.3 and 0.5 make 0.8. So now we're so close. We just need one more step. Let's mix up our colors here a little bit for fun. For the second step, we need to do the opposite of multiplying by 2. So what is the opposite of multiplying by 2? Well, it's going to be dividing, right? So this time I'm going to do my dividing line. Divide by 2. Whatever I do to one side, I always have to do to the other. Anytime you're solving equations, you have to do it to both sides. It'll be that way from now until forever, until high school, whether you do something in college, or in the real world. You're going to be, if you need to set up a quick equation, you have to do the same thing to both sides. Otherwise, you're going to be getting wrong answers. You won't get right information. So if you're building something, your lengths are not going to be right of your wood or whatever you're working on. Okay, so all this to say, what did we do? The first time we add 1.5 to both sides, right? And down here we divided by 2. Okay, and let's see what happens. 2 over 2, oh yeah, that's 1 whole. So now we have 1x is equal to, equal to 5.8 divided by 2. Okay, if we think about half of 5, that's going to be 2.5, right? And half of 0.8 is going to be 0.4. So that's going to be 2.9. Okay, so x is equal to, or 1x is equal to 2.9. Again, if you just have 1x, so we don't really need that, do we? All right, so x is equal to 2.9. Hopefully that's what you got. Let us keep on rolling. All right, número dos. We're going to look at this second question here. How do we get x by itself? That's the question we ask ourselves, right? Let's see if we can do a funky little highlighter. Okay, we want this blue guy by himself. Okay, how do we do it? If you're saying, hey, Mr. E, we have to isolate the variable. We need to do inverse operations. That's what you're saying? You're correct. So we have to do the inverse of subtracting 6. Opposite of subtracting 6 is adding 6. Whatever I do to one side, I have to do to the other. Otherwise, this scale, this side, would not be equal to this side. That's what we're saying here. It wouldn't be equal. All right, this goes away, right? Negative 6 and positive 6 cancel out. And now we're left with 3x is equal to negative 12, right? Negative 12. So now we have 3x equals negative 12. Sweet, we did one of our steps, right? Now we just need to do the last step. So that was our first step. Let's choose a different color. Let's do red. So opposite of multiplying by 3, again, would be dividing by 3. So that's what I'm going to do. Those are multiplying. I have to divide by 3 to make that 3 go away. Got to get rid of it so I can isolate my variable. All right, that's 1 whole, isn't it? So that is just 1x equals negative 4. Because 12 divided by 3 is 4. A negative divided by a positive term, that's an odd number of negative terms, guys. So that's going to be a negative answer. All right, so there is our answer. Let's choose a fun color to highlight. How about orange? All right, here is our answer. Okay, x is equal to negative 4. All right, so once again, I want you to try the next one, pause it, and see if you guys got the correct answer. Alrighty, so they are getting a little bit trickier here, right? We have our 4x plus 2.4 equals negative 3.6. Okay, if we need to solve, we need to do the inverse operations like we did before. Let's start with the adding here. That's going to be the easiest one to start with because it's separate from this 4 that's kind of tied up with the x. So the opposite of adding 2.4 would be subtracting 2.4. That's what we did to both sides, right? And then that would make it 0 right here from these guys, right? That becomes 0, and we have 4x is equal to negative 3.6 minus 2.4 more is now going to be 6 into the negatives. Right? And now we have 4x equals negative 6. To solve, all we need to do is do the inverse operation. Opposite of multiplying by 4 is dividing by 4. So you see we've divided by 4 on both sides. That just becomes 1 whole. So it's just 1x, okay, which just then becomes x. And on the right, we've got negative 6 over 4. So if we simplify this fraction, we can get negative 3. We can divide both top and bottom by 2. You can get negative 3 over 2. Okay. Or I guess you could also say negative 1.5 or negative 1.5. Right? Because if you cut negative 3 in half, you'd get negative 1.5. All right, so that is our answer. All right, last one as a class here. Isolate the variable. That's going to be our guy over here, right? We want to get this isolated. So how do we isolate? We're going to do the inverse operations, starting with our guy over here, because it's going to be easier to start with the addition and subtraction, right? So opposite of adding 8 would be subtracting 8. Do that to both sides. Okay, and now let's see, 8 minus 8 is going to become 0, right? So now we have, rewriting my equation, negative 2x plus 0, so I don't really need to write that, do I? Equals 4 minus 8. Let's see, if we subtracted 4, that would get us to 0, and then 4 more than that would take us to negative 4. So now we have negative 2x equals negative 4. Okay, to solve, we need to, again, do the inverse operations. This is negative 2 times x, isn't it? If there's no symbol. So we have to divide by negative 2. Divide by negative 2. So this becomes 1 whole. And now we have x is equal to 4 divided by 2 is 2, and a negative term divided by a negative term is a positive term. So we have x is equal to 2. Again, if I wanted to check, plug it back in, right? 2 times negative 2 is negative 4. Negative 4 plus 8 would then be 4. Okay, guys, so one last time, I want you guys to pause your screen, see if you guys can try this and get it correct on your own. Okay. All right, did you get it? Let's see. So we need to do inverse operations to solve for x. That would be subtracting 1.8 to both sides. So we put here, subtract 1.8. We do that to both sides, and we get negative 3x, because these cancel out, equals 2.7. Okay, 4.5 minus 1.8 gives us 2.7. Now the last step that we need to do here is we are dividing both sides by negative 3. So if I divide both left and right sides by negative 3, then let's see what we get. Negative 3 divided by negative 3 now becomes 1 whole, right? Negative 3 over negative 3. So that's just 1x. Or again, we can just say x. So now we have x is equal to 2.7 divided by negative 3. Not necessarily the easiest, but that is okay. Take our trusty dusty little calculator, 2.7 divided by, divided by negative 3. So we'll say divided by 3 and make it a negative 3 equals negative 0.9. Okay, so our answer is going to be what we just said, negative 0.9. Or if you want to put negative 0.9, you could put that as well, either way. So that is our answer. If we took this value, let's highlight this guy. Say we do this fun color here. Might be too dark. Oh, not too bad. Okay, so if we take this negative 0.9 and plug it back into the start, multiply those and add that, we should get 4.5. If not, then that's not our solution. All right, great job, guys. So time to practice. Let's try these two sets, okay? Again, as we go forward past this week, things will look a little bit different, differently. We will probably have some projects, a couple things like that mixed in where you'll have some more hands-on activities. Not that this is not hands-on. Hopefully you're following along at home and you are using the IXL links to practice before you take your quiz. But we'll try to mix things up a little bit to where once we get past some of this review, then we can look at maybe some new things and practice those. All right, so something to look forward to. All right, so, but if you look at these two links, one is IXL S9 and one is IXL S6, okay? So let me show you real quick what that's gonna look like. So IXL S9 kind of scaffolds it a little bit. This is what I want you guys to do first. And 8th graders, this is crucial. Make sure you go to 7th grade S9, okay? So you're gonna have to make sure when you go to math, you go to math, 7th grade S9, okay? So it kind of scaffolds it a little bit. You can see here, here's a two-step equation. It says, okay, subtract 2 from both sides. What's that gonna make here? And then it tells you to divide both sides by 12. So start with S9, okay, and then do the S6. Okay, the S6 will look like this, where it's just a two-step equation and it just says solve for J or solve for X. Okay, so you'll have to know, start with subtracting 4 first from both sides and then divide both sides by 2 next. Okay, you could do it a different way. You could divide everything by 2 on this one, I'm noticing. But easiest way, the way we've learned so far, is just to start with the furthest one out, subtracting 4. Okay, and if you need help on these, you can always go back down here to a different set or learn with an example here first. Okay, all right. Have at it, guys. S9, you need to get to 80 SMART score, and S6, you need to get to 90 SMART score. Okay, S6 will go on your grade, as will the quizzes I'm about to post. Okay, so make sure you do all 3 of those, and the S6 and the quiz will be on your grade. You only get 1 attempt on the quiz, so make sure you practice first and make sure you know your stuff. All right, thanks guys, good luck. Let me know if you have any questions.